I spent the better part of 2 months buried in declassified Signal Corps records, patrol reports, and veteran accounts from 152 Signal Squadron, the communications unit attached to the Australian Special Air Service Regiment in Vietnam. What I kept coming back to was a contradiction that shouldn't have existed. The Americans had poured billions into the most advanced tactical radio systems ever built. The Australians arrived in-country carrying radio sets designed by a company in Sydney using technology from the late 1940s. And somehow, against every expectation, against every assumption about modern warfare, it was the Australians who could talk when no one else could. When the jungle swallowed every American voice transmission whole, there was still one sound cutting through the static, the rhythmic pulse of Morse code, sent by Australians on radios their own allies had laughed at. June 1966, Nui Dat, Phuoc Tuy Province, South Vietnam. The heat is a living thing. It wraps itself around your chest at dawn and doesn't let go until well after midnight. The air is so heavy with moisture that breathing feels like drinking. And somewhere deep in the jungle south of the base, a 5-man Australian SAS patrol is crouched motionless under triple canopy so thick the midday sun barely touches the jungle floor. The patrol signaller, a member of 152 Signal Squadron, Royal Australian Corps of Signals, is hunched over a radio set that looks like something pulled from a museum. It's an AWA A510, a 4-channel crystal-controlled HF transceiver designed and built in Australia in the mid-1950s using circuit architecture that traced its roots to the late 1940s. The thing weighed more than anyone wanted to carry. Its voice output was a whisper, just 150 milliwatts. Most American signals officers would have taken one look at it and asked if it was a joke. But the signaller isn't using voice. His hand moves in precise, deliberate taps. Morse code, 10 words per minute, encoded with a one-time letter pad that makes every transmission unbreakable. And 50 kilometers away, in a sandbagged communications bunker on what the Australians called SAS Hill, an operator from 152 Signal Squadron copies the message without a single repeat request. What I found when I started pulling the records on this unit made me rethink everything I thought I knew about military technology. The most expensive radio in Vietnam couldn't do what this $50 relic could. And the reason why is a story almost nobody has told. To understand how absurd this situation looked to anyone watching it unfold, you need to understand what American military communications doctrine looked like in 1966. The United States military had just fielded the AN/PRC-25, known universally as the Prick 25, and it was considered revolutionary. Developed by RCA in the late 1950s as a replacement for the Korean War era AN/PRC-10, the PRC-25 incorporated pioneering solid-state circuitry. It was water-resistant, simple to operate, easy to maintain, and offered 920 channels across 2 VHF frequency bands. General Crichton Abrams, who served as deputy commander and then commander of MACV, reportedly called the PRC-25 the single most important tactical field item in Vietnam. And he had good reason to say that. The PRC-25 gave American platoon leaders something that had never existed before: instant voice communication from the field to headquarters. You picked up the handset, you pressed the button, you talked. No codes, no complicated procedures. Just your voice carried on VHF FM radio waves at 2 watts of power, theoretically reaching 8 kilometers with the long-range antenna. When Australian forces arrived and American signals officers saw what they were carrying, the reaction was, and I'm being diplomatic here, incredulity. I remember an American warrant officer looking at the A510 and asking us if we'd brought it from a war museum. One former 152 Signal Squadron operator recalled in a post-war interview. The A510 wasn't just old. It was a fundamentally different philosophy of communication. 4 channels, crystal-controlled, meaning you had to physically swap crystals to change frequency. 150 milliwatts of RF output on voice, compared to the PRC-25's 2 watts. That's roughly 13 times less powerful. But here's what the Americans didn't see, and what I kept finding in report after report. The Australians weren't planning to use voice at all. Reading through these early deployment records, I kept thinking, how did nobody on the American side stop and ask why the Australians were doing this? The answer, I eventually realized, was that nobody thought they needed to. The Americans had solved the communications problem. They had the best radios money could buy. VHF was the future. Morse code was something your grandfather did. What they didn't understand was the jungle. And the jungle didn't care how much your radio cost. The story of Australian tactical communications in Vietnam doesn't start in South Vietnam. It starts in a factory in Sydney at Amalgamated Wireless Australasia, AWA, where Australian engineers had been building military radio equipment since the First World War. By the early 1950s, AWA was producing the A510 transceiver, a portable, battery-operated, 4-channel crystal-controlled HF set covering 2 to 10 megahertz. The design philosophy was born from a very specific set of Australian military requirements that differed fundamentally from American thinking. Australia's military had spent decades operating in the jungles of New Guinea, Borneo, and Malaya. They knew, from brutal first-hand experience, that jungle warfare demanded communications that could penetrate dense canopy and reach distant bases, not just connect units within line of sight. Prototypes of the A510 had reportedly been tested under fire in Malaya during the emergency in the 1950s. The radio was refined for exactly the kind of small unit, long-range patrol work that would later define Australian SAS operations. Its HF frequency range of 2 to 10 megahertz meant that signals could propagate via ground wave, hugging the Earth's surface and bending around obstacles, or via skywave, bouncing off the ionosphere to cover distances of 100 miles or more when paired with a proper half-wave dipole antenna. When the Australian SAS began deploying to Vietnam, the signals personnel came from 152 Signal Squadron, a unit with a unique identity within the Australian Army. Members of 152 SIG Squadron undertook the same grueling selection and reinforcement cycle training as the SAS troopers themselves. They were known affectionately as Chooks by the SAS operators, but make no mistake, these were fully integrated members of 5-man SAS patrols, expected to move through enemy territory with the same stealth as any other trooper, while carrying one of the heaviest loads in the patrol due to the weight of their radio equipment. The main body of 3 SAS Squadron flew from Perth to Saigon on a chartered Qantas Boeing 707 on June 15, 1966. Included in the squadron were members of 152 Signal Squadron as a 3 SAS Squadron signal troop, commanded by Sergeant Daryl Croucher. When they arrived at Nui Dat, they found themselves desperately short of proper equipment. The AN/PR C64 sets they were supposed to use didn't have batteries. The AN/UR C10 emergency radios were in short supply. They didn't even have their one-time letterpad codes. So what did they do? They pulled out the vintage A510 radio sets and started patrolling. And here is where the story gets remarkable. Because those vintage radios worked, not just adequately. They worked in conditions where the Americans' far more expensive, far more modern equipment was failing. The reason was physics. Pure, unyielding physics. and the Americans had bet on the wrong frequency band. The fundamental problem with American tactical communications in Vietnam was one that no amount of money or engineering could fix because it was built into the basic laws of radio propagation. The AN/PRC-25 and its successor, the AN/PRC-77, operated on VHF, very high frequency, in the 30 to 76 MHz range. VHF signals travel in essentially straight lines. They are line of sight. A VHF antenna placed 3 meters above the ground has a theoretical range of approximately 7 kilometers across flat, open terrain. But Vietnam wasn't flat, open terrain. Nearly half the country was covered by jungle. And jungle canopy does something devastating to VHF signals. A U.S. Army Field Artillery manual published during the war estimated that jungle vegetation reduced VHF radio ranges by 10 to 60%. I found that number and stared at it. 10 to 60%. That means a radio with a theoretical 8-kilometer range could, in heavy jungle, be reduced to as little as 3 kilometers. For an SAS patrol operating 40 or 50 kilometers from base, deep in enemy-controlled territory, that wasn't a range reduction. That was total communications failure. The Americans knew about this problem. They tried to solve it with retransmission sites, placing relay radios on hilltops and elevated positions to bounce VHF signals over the canopy. They developed improvised jungle antennas that could be hoisted into the tree canopy. Special forces units used long wire antennas strung between trees. These were creative solutions, and they helped. But they were workarounds for a fundamental limitation. VHF was the wrong tool for the job, and everyone at some level knew it. Now compare this to what the Australians were doing. HF, high frequency, radio operates in the 2 to 30 MHz range. At these frequencies, radio waves behave completely differently. They can propagate as ground waves, following the curvature of the Earth and bending around obstacles, including dense jungle. They can also propagate as sky waves, refracting off the ionosphere and returning to Earth hundreds or even thousands of kilometers away. The jungle canopy that ate VHF signals alive was far less of an obstacle to HF ground waves. And then add Morse code to the equation, and the advantage becomes overwhelming. Morse code, continuous wave, or CW transmission, uses a bandwidth of just 100 to 150 Hz. A voice transmission on SSB uses roughly 2,400 Hz. That means Morse code concentrates all its transmitted power into a signal roughly 15 to 20 times narrower than voice. In practical terms, this means a Morse signal can be detected and copied at signal levels where voice would be nothing but unintelligible noise. The human brain's natural ability to pick out a pure tone from background static, what radio operators call aural selectivity, makes weak CW signals readable in conditions where voice signals have long since disappeared into the noise floor. This is what an Australian SAS signaler was doing every time he tapped out a message on the A510, and later on, the AN/PRC-64 once batteries became available. He was sending a razor-thin signal through the jungle on a frequency band that the canopy couldn't block, using a modulation method that could be copied at power levels far below what voice required. And he was doing it encrypted, using one-time letterpad codes that were mathematically unbreakable. The patrol normally maintained 2 routine signal schedules per day, transmitted in code using the OTLP system. Each patrol operated on different times, allowing the base station, manned by 152 Signal Squadron operators in the communications bunker on SAS Hill at Nue Dat, to handle patrols in orderly succession without congestion. It was methodical. It was disciplined, and it was, in the jungle environment, functionally invincible. When I first came across the patrol logs showing consistent comms from distances that should have been impossible for the equipment they were carrying, I didn't believe what I was reading, I have to admit. But every source confirmed the same thing. The AI-510's 150 milliwatts of voice power was pathetic, but nobody was using voice. On Morse, with a proper antenna, that same radio's HF signal was reaching back to Nui dot from distances that would have been unthinkable for any American VHF set. The Americans eventually noticed. The U.S. Army Special Forces, the Green Berets, had their own HF Morse capability using the GRC-109, a set with roots going back to the CIA's RS-1, and later the AN/PRC-74. They understood the principle, but the conventional U.S. Army had largely abandoned HF Morse at the tactical level in favor of VHF voice. It was faster, it was easier, it required less training, and in open terrain, it was superb. But the conventional Army was fighting in jungle, not open terrain. And a communications gap had opened that nobody at Signal Corps headquarters seemed willing to acknowledge. As the war progressed, both the communications technology and the tactics evolved. But they evolved differently for each force. For the Americans, the trajectory was predictable. More power, more technology, more complexity. The AN/PRC-25 gave way to the AN/PRC-77, which entered service in 1968. The PRC-77 replaced the single remaining vacuum tube in the PRC-25 with a transistor, making it lighter and more battery efficient. It added compatibility with the TSEC/KY38 Nestor voice encryption system. On paper, it was a significant improvement. But the fundamental limitation remained. It was still VHF. It was still line of sight. And the jungle still ate the signal. The more I mapped out these encounters, the clearer the pattern became. American units operating under heavy canopy consistently reported comms difficulties, while Australian SAS patrols operating in the same areas maintained contact. The Americans compensated with infrastructure. VHF retransmission sites were established on hilltops throughout the tactical area of operations. Aircraft were used as airborne relay platforms. The first Australian task force itself used VHF retransmission equipment, including an ingenious arrangement where SAS signals personnel at Nui dot launched a VHF retransmission antenna on a tethered balloon from SAS Hill to extend the range of VHF communications for patrols operating close to the base. But here's the critical insight I found in the signals records. The balloon and the retransmission sites were supplements to the HF Morse network, not replacements for it. The HF link was the backbone. It was the comms that never failed. When everything else went down, when the retransmission site was fogged in, when atmospheric conditions degraded VHF propagation, when a patrol was deeper in the jungle than VHF could reach, the Morse key was still there. For the Australians, evolution meant refinement of an already sound system. The A510 was gradually replaced by the American-made AN/PRC-64 once battery supplies and crystals became available in late 1965 and into 1966. The PRC-64 was still an HF set, still used primarily for Morse, but it was smaller and lighter than the A510. Critical considerations when every ounce in a patrol signaler's pack mattered. Interestingly, 15 PRC-64 sets had been evaluated by the 5th Special Forces Group in 1965 and were found to have unreliable voice capability. But their Morse performance was equivalent to the larger GRC-109 in a far more portable package. By the late 1960s and into the early 1970s, AWA was producing the PRCF-1, originally designated the A512, a fully solid-state HF transceiver that covered 2 to 12 MHz in 1 kHz steps, giving operators access to 10,000 channels. It produced 10 watts of power on SSB, weighed roughly 20 pounds with accessories, and represented everything AWA had learned from a decade of jungle warfare. The PRCF-1 didn't completely replace earlier sets in all roles until the early 1970s, but it represented the culmination of a philosophy that had been vindicated over years of operational testing in the worst radio environment on Earth. The Vietnamese adapted to Australian communications as well, or rather, they tried. Captured Viet Cong documents showed that they were aware the Australians communicated differently from the Americans. Direction-finding equipment could detect HF transmissions, but the brevity of Morse bursts, especially coded traffic sent at speed, made intercept difficult and exploitation nearly impossible given the OTLP encryption. The Viet Cong came to call the Australian SAS Ma Rung phantoms of the jungle, and the inability to detect or predict their movements was a significant part of what earned that name. When a 5-man patrol can materialize in your rear area, observe your movements for days, call in devastating fire support, and vanish without ever having made a sound loud enough to detect. Your communication system is not just adequate, it's a weapon. By 1968 to 1969, the Australian SAS had reached its peak operational tempo in Vietnam, and the communications architecture built on HF Morse was performing at extraordinary levels. Consider the numbers. During its entire deployment in Vietnam, approximately 580 men served in the Australian SAS. Operating in 5- and 6-man patrols, they killed at least 492, and possibly as many as 598 enemy combatants. Their own killed-in-action losses totaled 2 men, with 3 additional fatalities from friendly fire, 1 missing, and 1 death from illness. 28 men were wounded. That is a kill ratio that staggers the imagination, roughly 250 to 1 against confirmed enemy dead. Those numbers don't exist without communications. Every one of those patrols depended on reliable contact with base. Every ambush, every surveillance report, every call for extraction or fire support ran through the communications link maintained by 152 Signal Squadron. If that link failed, a 5-man patrol 50 kilometers behind enemy lines wasn't a reconnaissance asset. It was 5 men alone in a jungle full of people trying to kill them. The reliability of the HF Morse system meant that SAS patrols could operate at ranges and in terrain that would have been suicidal without communications. It meant intelligence could flow from the field to task force headquarters in near real time. It meant that when a patrol was compromised and needed emergency extraction, the call went through, not sometimes, not when conditions were right, but consistently. The communications bunker on SAS Hill at Nui Dat became the nerve center of one of the most effective special operations capabilities in the entire Vietnam War. Operators from 152 Signal Squadron maintained round-the-clock radio watch, copying Morse traffic from patrols scattered across Puoc Tuy, Bien Hoa, Long Con, and Binh Thuy provinces. Signal detachments were also deployed to retransmission sites at locations including Duc Than and VC Hill, extending the reach of both HF and VHF networks. The irony is breathtaking. The world's wealthiest military spent billions on communications technology, satellites, relay systems, encryption suites, solid-state VHF radios that were genuine engineering marvels. And in the jungle that defined the war, a technique that predated the transistor, running on equipment designed in a Sydney factory using principles from the 1940s, outperformed it all. As one Signal's veteran noted in a post-war reflection, the problem was never the technology. The problem was choosing the right technology for the environment. The Americans had the best VHF radios in the world. The Australians had the right radios for the jungle. The lessons of Australian SAS communications in Vietnam rippled far beyond that war. The principle that newer and more expensive does not always mean better, that the environment dictates the technology and not the other way around, resurfaced in every subsequent conflict involving jungle, mountain, or otherwise radio-hostile terrain. HF radio, which the conventional U.S. military had been steadily sidelining in favor of VHF, UHF, and satellite communications, experienced periodic renaissances precisely because of lessons first demonstrated in Vietnam's triple canopy. When satellite links went down in remote Afghan valleys or Iraqi urban canyons, it was HF that filled the gap. Companies like Harris Corporation and Rockwell Collins would eventually pour resources into modernizing HF technology, applying software-defined radio architectures to eliminate the atmospheric quirks that had given HF its reputation as unreliable. For the Australian military, the experience validated a culture of pragmatism that extended well beyond radio equipment. The Chooks of 152 Signal Squadron had proved that a well-trained operator with an old radio and a Morse key could outperform a poorly matched system costing orders of magnitude more. It was a lesson about institutional humility, about listening to the environment instead of imposing doctrine upon it. When I started researching this story, I expected to find a simple tale of old equipment being replaced by new equipment. Instead, I found something far more interesting. Old equipment being vindicated by the only laboratory that matters: combat. The A510, that museum piece the Americans laughed at, worked when the most advanced tactical radio in the world didn't. Not because it was better engineered, but because the Australians understood something the American Signal Corps had forgotten. Sometimes the jungle doesn't need to hear your voice. It just needs to hear your heartbeat, tapped out in Morse, one letter at a time, at a